Good morning. In this lecture we will discuss electronegativity, another periodic property. So by definition, if you see, electronegativity is the tendency of bounded atom to attract the shared pair of electron towards itself. Tendency of bounded atom to attract shared pair of or bond pair of electron toward itself is called electronegativity. Like if we have a bond between hydrogen and hydrogen, when these two hydrogen they form a bond, that the bond pair of electron between these two, like you draw like this, that will lies exactly at the center. So this bond pair lies exactly at the center, because both the atoms are same, both have a similar tendency to attract this bond pair toward itself. ये भी इसको खींच रहा है, ये भी इसको खींच रहा है, लेकिन दोनों की टेंडेंसी सेम होने की वजह से बॉन्ड पेयर लाइज एग्जैक्टली एट द सेंटर. Similar happens when the bond is in Cl. Again, the bond pair will lies in the exactly in the center. Now, if I attach hydrogen with chlorine, now in this case the bond pair will not lie exactly in the center. See where it will go. It will move just towards, so this is your center. But this bond pair of electron lies toward chlorine. Why it is so? Because chlorine has a more tendency to attract electron as compared to hydrogen. So this tendency of an bounded atom to attract the shared pair of electron toward itself is called electronegativity. This property is called electronegativity. Now from this we can say that we can conclude that electronegativity of chlorine is more than hydrogen, isn't it? So when the bond is formed between two similar atoms like hydrogen, chlorine, there is no charge on any atom. Both are neutral. This you can say is a pure covalent bond. Pure covalent bonds. When the bond is formed between two dissimilar atoms like H and C, what happened is that lone pairs they moves toward chlorine. Bond pair they moves toward chlorine like this. You can draw it like this. Say this is the electron cloud that moves toward chlorine because chlorine has a more electronegative. As a result, what happened? This chlorine, because here is a more electron density, get partial negative charge, and this hydrogen, because here is a less electron density, get partial positive charge. So this bond is not a pure covalent bond. Okay, if you say these two bonds are non-polar, 10th में भी शायद पढ़ा होगा, non-polar covalent bond, and this is known as a polar covalent. It has some ionic character. Cl has some ionic character. It is not a pure covalent. It has some ionic character. So ionic character is because of the electronegativity difference. So what the electronegativity is a tendency of a bounded atom to attract the shared pair of electron toward itself. Like when you draw the structure of water. Okay. So this oxygen will be negative, the hydrogen will be positive. Why? Because oxygen is more electronegative. So it attracts the shared pair of electron toward itself. electron density is more around the oxygen, like in this in chlorine, and less electron density will be there around the hydrogen. So due to electronegativity, ionic characters come. Molecule or compound become little bit ionic, and that causes the you can say that moves toward the stability. When the compound gets some ionic character, it means it's going to be more stable. Because ionic bonds are stronger than covalent. They are a strong force of attraction. When there is no charge, then what is the binding force here? This binding force is weak, because there is no charge. Now, due to this electronegativity difference, charge 12. When the charge 12, it means the oppositely charged atoms, they attract each other strongly. It means the molecule is going towards more stability. Okay, when you combine H2 plus Cl2 to form HCl, why this reaction is feasible? What is actually this? This is your H2 plus Cl2 to form HCl2. What happened here is a pure covalent. These are pure covalent bonds. They're going to change into a partial ionic. So HCl is more stable, then only this reaction is feasible. So HCl is more stable than HH and Cl. But what is there is HH. What is there is a ClCl. What is formed here is a new bond HCl. Which is more stable? This is more stable. Because there is a charge, and due to charge they attract each other. There is no charge, so their attraction is not so strong. Okay. So based upon this, that ionic compounds are more stable. From करेंगे अभी Pauling electronegativity scale, that is totally based upon this concept that ionic compounds are more stable than covalent. Now, this is about the electronegativity. Now, we will do the variation of electronegativity. Variation of electronegativity in periodic table. A part, long group, top to bottom. What happened in top to bottom? Say, if I add here fluorine, chlorine, bromine, iodine, group number 17. Okay. Atomic number is Z, 9, 17, 35, 53. If we talk about the nuclear charge, that increases because nuclear charge, Z is nuclear charge here, not atomic number. That increases because the nuclear charge increases with atomic number. But we talk about the Z star, effective nuclear charge, that remain constant, because shell also increase. Okay, when you move towards the shell means N, that also increase. So what happened overall is radius or N, that also increase. Size बढ़ रहा है. What is Rn? Rn is the size. आयोडीन सबसे बड़ा है, फ्लोरीन सबसे छोटा है. Okay. You say what is the electronegativity then? Force of attraction. If you say talk about like force of attraction. Force of attraction that is equal to I will write the formula here. Like F equal to K. Constant Boltzmann Z E square by R and radius square. जितना रेडियस ज्यादा होगा उतना ही फोर्स ऑफ अट्रैक्शन कम होगी. इसका मतलब फोर्स ऑफ अट्रैक्शन जो है वो फ्लोरीन में सबसे ज्यादा है. जब हम कहेंगे डाउन द लो फोर्स ऑफ अट्रैक्शन जो है वो क्या हो रही है, डिक्रीज हो रही है. ओके, अगर डिक्रीज हो रही है तो फिर इलेक्ट्रोनेगेटिविटी वो भी क्या हो रही है, डिक्रीज हो रही है. सो इलेक्ट्रोनेगेटिविटी ऑफ फ्लोरीन इज मैक्सिमम इन द periodic table. Maximum. 4 इसकी वैल्यू पॉलिंग स्केल पे 4 है, 4, 3.5, 2.8, 2.1 like that. So fluorine is the most electronegative element in the periodic table. Let's see once again. Nuclear charge increase, but effective nuclear charge remain constant because number of shell increase. Down the group number of shell increase. Obviously radius increase, size बढ़ रहा है. साइज बढ़ रहा है तो न्यूक्लियस की और आउटरमोस्ट इलेक्ट्रॉन की जो फोर्स ऑफ अट्रैक्शन है वो कम हो रही है तो फिर वो एलिमेंट इलेक्ट्रॉन को अट्रैक्ट नहीं करेगा, तो इलेक्ट्रोनेगेटिविटी जो वो डिक्रीज हो रही है. दिस इज अबाउट द ग्रुप. सेकेंड वी विल टॉक अबाउट द पीरियड. लॉन्ग पीरियड, left to right. Take an example of second period: lithium, beryllium, boron, carbon, hydrogen, oxygen, fluorine. Okay, when you move this side, both Z and Z star. When you move this side, they increases. Nuclear charge increases. Number of shells remain constant. Radius means size. ये पढ़ा हुआ size that decreases. Then F will increases, and electronegativity that will increases. So when you move along a period from left to right, electronegativity that increases. When you move in a group from top to bottom, electronegativity decreases. This is the variation of electronegativity in the periodic table. Next is about the scales. Electronegativity scale. Pauling. Same thing, let's consider reaction. Like if we have a hydrogen combined with XX, X means any hydrogen, you get 2HX. Okay. So what we discussed earlier, that these two bonds, they are non-polar. And there is a charge developed, that is a polar. Another thing is, these two bonds are purely covalent, and this is a partial ionic character. Overall, we can say this HX is more stable because of the force of attraction that increases. So the electronegativity difference between the two atoms make the molecule stable. So with respect to hydrogen, in Pauling scale, hydrogen is a standard. If we write here IX, IH, this is chi. Symbol is chi, CHI, chi. That represents the electronegativity equal to 0.208. And delta H of HX. यहाँ हम सीधे delta लिख देते हैं. So this is the formula. Here chi X and chi H are the electronegativity, and delta HX is the extra bond energy. This is the enthalpy change during this process. Okay, that is the enthalpy, extra bond energy we कह सकते हो. That is extra bond energy in kilocalorie per mole. So this is the formula. So it can be written like this, that this delta Hx is equal to E of Hx minus the root of E of Hh and E of Xx and multiply E of Xx. So these values, that EHx, EHH, EXX represent the bond energy. So these values, this is bond energy of Hx. This is bond energy of HH. This is bond energy of XX. So this can be calculated like this, which is used in this formula. If we want to represent it in kilojoule per mole, just change the value to 0.1017. So you can write it chi x chi h 0.1017 root delta h hx. So these are the formula. Now here this energy is in kilojoule per mole. यहाँ पे थी किलो कैलोरी पर मोल, अब आ गया किलो जूल पर मोल. So this is about the Pauling scale to find the electronegativity difference and to find the electronegativity of any atom with respect to hydrogen. So next is the more the electronegativity difference, more is the ionic character. Means you can say, if you draw like this, and here is the En difference, and along this side, but there is a percentage of 0, 50, 100, percentage of ionic character. The graph will be like this. It will be 50%. Ionic. When the electronegativity difference is, say here is 1, 2, 3, 4, exactly 1.7. Okay. Compound is, there is no electronegativity difference like hydrogen. Electronegativity difference is 0. Compound is purely covalent. As soon as electronegativity difference takes place, then ionic character increases, covalent character decreases. If you say chi x, chi h, exactly 1.7, then bond is 50% ionic. You can also say 50% covalent. If this difference is more than 1.7, so this difference is more than 1.7. जितना difference ज़्यादा होगा उतना ionic character बढ़ेगा. तो हम क्या लिखेंगे? More ionic, less covalent. And if this difference is, say chi x, chi h is less than 1.7, then the reverse is this. Bond is more covalent, less ionic. 50% ionic, 50% covalent will be there when the electronegativity difference is exactly 1.7. Okay. So this is based on the Pauling scale of electronegativity. Now come to next scale, that is, so according to this we can also write that HF, HCl, HBr, HI. Electronegativity of hydrogen is 2.1. Electronegativity of fluorine is 4, is 3.5, is 2.8, is 2.5. What is the difference here? Electronegativity difference. Here is 4 minus 2.1, 1.9. Here is 3.5 minus 2.1. Here is 2.8.7. Here is 0.4. Electronegativity difference that decreases. With decrease in electronegativity difference, we can say ionic character decreases. So out of these four molecules, HF, HCl, HBr, HI, the most ionic is HF. Least ionic is HI, or you can say the most covalent is HI. In this way we compare the covalent and ionic character with the help of electronegativity difference. Next is a Millikan scale. Its full name is Millikan-Jaffe electronegativity scale. So electronegativity, according to this, is regarded as the average value of electron affinity and ionization energy. Because electronegativity and ionization energy affect the electronegativity, as electronegativity is force of attraction. जिसकी आयनाइजेशन एनर्जी कम होगी वो तो इलेक्ट्रॉन देगा, जिसकी आयनाइजेशन एनर्जी ज्यादा होगी उसकी इलेक्ट्रॉन एक्टिविटी भी ज्यादा होगी, जिसकी इलेक्ट्रॉन एफिनिटी ज्यादा होगी उसकी इलेक्ट्रॉन एक्टिविटी भी ज्यादा होगी. देयर इज अ डिफरेंस बिटवीन द इलेक्ट्रॉन एक्टिविटी एंड इलेक्ट्रॉन एफिनिटी. For school exam, you may ask in the exam the difference between these two. So first is this is the property of bounded atom. This is the property of isolated atom. इलेक्ट्रोनेगेटिविटी क्या थी? एक एटम है, वो कितनी टेंडेंसी से एक एक्स्ट्रा इलेक्ट्रॉन ले रहा है, सिंगल एटम. और ये किसकी प्रॉपर्टी है? बाउंडेड एटम. दो बाउंडेड एटम हैं और शेयर पेयर ऑफ इलेक्ट्रॉन को वो कितनी टेंडेंसी से खींच रहे हैं. दैट इज मेजर डिफरेंस. सो इट इज relative value with respect to hydrogen. With respect to hydrogen, because the electronegativity value of fluorine is 4. It is absolute value, no relation with other. Okay, so these are the two major differences between the electronegativity and electron affinity. Now, in case of electronegativity, when the electron is added, the species changes to negatively charged ion. Electronegativity में ऐसा कुछ नहीं होता. Charge developed due to the movement of electron cloud from center to one side where the electronegativity is more. Okay. Next is based on this. Next scale is Millikan Arnold scale. Next third one is. So that's a ratio of electron affinity and ionization energy is a Millikan scale. In Millikan scale, the values are generally 2.8 times more than the Pauling scale. Okay. Next is Aldred Rochow Electronegativity scale. This is another scale. They define the electronegativity as the force exerted by the nucleus of an atom on the valence electron. How they define electronegativity? Force exerted by the nucleus of an atom on its valence electron. On its valence electrons. So electronegativity, according to this, is represented as En equal to 0.359. That's a fixed number. Z effective by R square plus 0.744. Here Z effective is effective nuclear charge, R is the covalent radius. The relative electronegativity value of different element is the same. Scale is extremely helpful for applying in the various concepts like bond formation, the ionic character. So this is all about the electronegativity. So electronegativity difference, how the electronegativity difference affect the nature of bond, whether it is ionic or covalent, and this variation in the periodic table. You just memorize this formula just for not in the your school will ask about this. So the first Pauling scale formula, that is very important, that can be asked. Otherwise, the relation, that graph that we have drawn, that if the electronegativity difference is exactly 1.7, the bond is 50% ionic, 50% covalent. That concept is very important.